what up, what up? I'm the math teacher Goat, and this is a very important lesson when it comes to logs, the exponential and logarithmic equations and inequalities lesson. That's 2.13. So this is a full lesson. Notes are in the description. Make sure you click the description, download those, like and subscribe, leave a comment. Let's just jump right into it, shall we? Stuff that we should already know, okay? Simplify the following into a single log. This is an ln. And ln's behave just like logs because ln is just a log. Going left to right, we would look at ln2 plus ln5 and say when you add logs of the same base or ln's, you multiply the insides. So that becomes ln of 10. And then you have minus ln of 3, lingering like an awkward friend at a party. Now, when you subtract logs of the same base, or ln's, you divide the insides. So this becomes ln of 10 divided by 3, which is going to be you, Mr. A, or Ms. A, or Mrs. A. Any of the A's. Sketch a typical logarithm and answer the following. All right, well, a typical logarithm look a little something like this. Okay. You're going to hover to the right side of the y-axis, but you're never going to touch it. So like the y-axis acts like a vertical asymptote, and then you curl up this way. So when we look at the domain is only positives. So like from 0 on to infinity, you can't even include zeros, which means you can't take the log of a non-positive number. So you can't take the log of a negative number. You can't take the log of a 0. Okay, you can only take logs of positive numbers. All right, now this lesson is focusing on solving logarithmic and exponential equations. We've done it kind of before, but now we're going to really get into it. So the first thing that we're going to look at is if you see two logs of the same base equaling each other, and that's it, a single log base b equals a single log base b, then the insides are just going to equal each other. Very similar to like a same base with exponents. This is the same thing. Why does that matter? Well, let's take a look at these guys right here. I have log base 3 of stuff equals log base 3 of stuff. Set the stuff equal to each other. K minus 1 equals 8. Add 1 to both sides. K equals 9. K9, like the dog. Fun fact, my neighbor has a dog named Ki, and I purposely have mispronounced his name as Keanu every single time I've had conversations with my neighbors. It's fun. It's fun. Now, wait a minute. Wait a gol-darn minute. We don't have a single log equal a single log, but I know what I can do. When you add logs of the same base, you multiply the inside. So that's going to look like this. Log base 3 of x plus 4 times x minus 2 is going to equal log base 3 of 20. Now, we can get rid of those logs. But oh, are we not done? Not even close. X plus 4 times x minus 2. In fact, we're going to have to do a lot extra for this one. A lot extra. Foil that out. Foil that out so you get x squared. Now let's wave our hands because I don't have all the space in the world. Minus 2x plus 4x is going to be plus 2x minus 8 equals 20. Let's add 8. Let's add, nope, I don't know why I said add 8. Let's subtract 20. Stupid me. Subtract 20. Subtract 20. And you get x squared plus 2x minus 28 equals 0. Ugh. That's not factorable. So, all right. I regret my decisions. So I'm going to, in very small print down here, I'm going to use the quadratic formula. That is not factorable. Why did I do that? If that was just a 3x, all right. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. If I hadn't said it already, boys and girls, that's the quadratic formula. A would be invisible 1, B would be 2, C would be negative 28. All right, so that's going to be negative 2 plus or minus the square root of 2 squared minus 4 times 1, thank God, times 28, all over 2 times 1. So that's going to be negative 2 plus or minus the square root of 4. That's supposed to be negative. I knew I messed something up there. 112 plus 112 all over 2. That's going to be negative 2 plus or minus the square root of 116 all over 2. Now, even though it's against my faith to take the square root of 116, it is divisible by 4, so that would bring out a 2, but that really won't help me. I want the decimal version of this because I feel like that would be helpful for really answering what I wrote up here. So I'm going to be cheap and use Siri. What's the square root of 116?
The square root of 116 is approximately 10.7703.
All right, so we'll do that all over 2. So we have two options. Option number 1 is negative 2 minus 10.770 all divided by 2. So let's do this. So that would be negative 12.770 divided by 2. Negative 12.770 divided by 2. It's negative 6.385. And the other option would be 8.770 divided by 2. What's 8.770 divided by 2? 4.385. All right. This is where we have to be really careful. Okay. Up there. So I'll write this a little bit bigger here so I can scroll back up. So I have our two options are negative 6.385. And if you're like, what? Why aren't you just circling the answer, sir? Mr. Math Guy, sir, Mr. Math Goat friend. Why not? Well, because I have to plug these numbers into the original problem. And if any of these would become negatives, that number doesn't count. Okay? Because log can't be negative. So, for example, if I take negative 6.385 and plug that up here, negative 6.385, that would get me log base 3 of negative something, which means I can't do that. That one won't work. So sometimes you have to go back and check your answers to make sure you could use them in the first place. So you won't work. If I plug in 4 point something, I'll get 8 point something. If I plug in 4 point something, I'll get 2 point something. You will be correct. But with these types of problems, you have to go back and plug your answer in just to make sure it works. Now, why didn't I do that over here? Why didn't I do that over there? Because I knew 9 minus 1 would be fine. Okay? So that's kind of the trick with some of these wacky ones like this. You need to plug them back into the original problem to see if you get a 0 or a negative inside the log. If you do, that number doesn't count. All right? All right. 3 minus log base 2 of x plus 7 equals log base 2 of 5. All right, so this is how I'm going to handle these. I'm going to move all the logs to one side because this no longer follows that rule up here. I'm going to move all the logs to one side of the equal sign and combine them. Okay, so I'm going to add log base 2 of x plus 7, add log base 2 of x plus 7. That crosses you out. That leaves me with 3 equals log base 2 of 5 plus log base 2 of x plus 7. Now I can simplify these into one single log, and it's going to look like this. 3 equals log base 2 of 5 times the quantity x plus 7, close it. Now, I don't know what to do here. I have no clue. But you know what I can do? If I get rid of that log, that makes life a lot easier. If I base 2 both sides, you've seen me do this before, 2 log base 2 cancels each other out. 2 to the third is 8. And so now I have 8 equals, drop this down, 5 parentheses x plus 7, close parentheses, and now that's much more manageable. Not the prettiest thing in the world, but not much more manageable. That becomes 5x plus 35 equals 8. If I subtract 35 from both sides, that gets me negative 27 equals 5x. Divide both sides by 5, divide both sides by 5, and that gets me negative 5.4 equals x. Now we go back over here and see, can I plug in negative 5.4? Yes, 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 I can. If I plug in negative 5.4, that gives me log base 2 of 1 point something. That's perfectly fine. So negative 5.4 is an acceptable answer, or we could have left it at negative 27 over 5. Either of these would have been okay. I just chose this one because I could easily do the math in my head and make sure the log worked. Okay, so negative 5.4 is the answer. Again, we have to check our answers and plug them back in. It's not a matter of can we get negative answers? Sure, we can get negative answers. We just have to make sure that if we plug them in, the log inside is not negative. All right. Let's take this guy, divide everything by 3, divide everything by 3, cross you out. That leaves me with 2 to the x plus 2 equals 4. Now, before you whip out the log, oh boy, before you decide to use log, don't. Because you might remember from something that I hinted at earlier, if I wanted to, I could just turn 4 into 2 squared. And so I now have 2 to the x plus 2 equals 2 squared. When you equal terms of the same base, the exponents are also going to be equal to each other. So this becomes x plus 2 equals 2, x plus 2 equals 2, subtract 2 from both sides, x equals 0. Now, I'm allowed to plug 0 in. If you're worried about plugging negatives into these guys, negative exponents are fine. We know what happens with negative exponents. It's negative logs and 0 logs that are bad news. That's what we have to be careful of. All right, let's keep going. Minus 3, that gets me log of x plus 6 equals negative 1. Okay, now what I need to do is I need to take the base 10 of both sides to get rid of that log. Okay, why base 10? Because that's invisible base 10 right here. So you cross out, leaving me with x plus 6 equals 1 over 10. Subtract 6, right? And let's put this back into decimal form because why not? That's going to be 1/10 minus 6, which is negative 5.9. Okay, negative 5.9, or negative 59 over 10. Again, I like the decimal version of this because then I can plug it in nicely up here and say, can I plug in negative 5.9? Yep, negative 5.9 plus 6 is positive, so we're good. So you are a legitimate answer. This one, I like it. I like it. First off, let's rewrite it as ln of x minus 12 to the 1/2. What I can do is, since that 1/2 is there, right, I can bring that out front, make that 1/2 ln of x minus 12. Now, if you're like, why don't you just square both sides? I can't, because that 1/2 still technically lives inside the ln, just like the square root did. So it's not as simple as that. You have to bring that 1/2 out front. So that's going to equal 4. Okay? Multiply both sides by 2. And you get ln of x minus 12 equals 8. Now, without the use of a calculator, I have to get rid of that ln. I'm going to do that by base e-ing both sides because e and ln cancel each other out. So that leaves me with x minus 12 equals e to the 8th, whatever the heck that is. I'm not going to worry about it. I'm going to leave e to the 8th in my answer. You can do that. Let's add 12. And my answer is going to be x equals e to the 8th plus 12. Okay, e is 2.718, so e to the 8th is a ridiculously huge number. And a ridiculously huge number plus 12 is going to be a whole lot bigger than 12. So I could plug that in. That would work just fine. Unique problem. I like it. Now, what we're going to see is something that we saw at the beginning here. Let's combine these two logs. Okay, so this is going to be, since they're adding logs of the same base, multiply the inside. So that's log of 3 times the quantity 2x plus 7, close it, equals log times the quantity x plus 6. Log equals a log means we can get rid of the logs. So that leaves me with 3 times 2x plus 7 equals x plus 6. Distribute that, 6x plus 21 equals x plus 6. Subtract x, 5x plus 21 equals 6. Minus 21 from both sides, and that gets us 5x equals, negative 15. Divide by 5, and x equals negative 3. Am I allowed to plug in negative 3? Yes, negative 3 plus 6 is 3. Am I allowed to plug in negative 3? 2 times negative 3 is negative 6. Negative 6 plus 7 is 1. Negative 3 is a legitimate answer. Whew. Close one. All right, let's use a calculator to solve. So what we'll do is we'll do as much as we can, and then we'll pull up our calculator. I guess we'll use, it doesn't really matter. We'll use the TI-84 Plus. We'll pull up our calculator and let the calculator do the rest. So, thank goodness only one of those. All right, we got to get that x all by itself, so let's ln both sides, and this is where we're going to need our calculator. Okay, so in fact, we don't need a calculator. I'm just going to, we do need a calculator. I'm not going to go off to the side and figure it out. This one, just go to your regular calculator and find out what ln of 3.65 is. Okay, I'm going to quick do that and let you know what I got. All right, so Mr. Calculator says it's 1.295. So negative x equals that, which means positive x equals negative that. Rounded 3 decimal places. All right, I don't even think I need a calculator for this one, but we'll see what happens. Let's do this first. Let's divide both sides by 9. Divide both sides by 9. So that gets you 1 over 27 to the x over 3. That is gross, equals 9. Okay, so what I want to do now is I want to, that x over 3, don't really like it. Let's cube both sides to get rid of it. Let's cube both sides to get rid of it. And what that does is that allows you to cancel out, leaving us with 1 over 27 to the x equals, what is that? 9 to the 3rd. 81 times 3 is 729. All right. So this is going to be gross. So that was 9 to the 3rd, which would make the right side 3 squared to the 3rd, which is 3 to the 6th. And over here, we could write this as, if I move that 27 up, I can write that as 3 to the negative 3rd. Right, to the x. Which means I could write it out as 3 to the negative 3x equals 3 to the 6. Now that I have the same exact thing, I can write that out. Negative 3x equals 6, divide by negative 3, divide by negative 3. X equals -2. No calculator needed, but boy, was that an ugly problem. Yuck. Did not like that one at all. All right. F of x equals this, g of x equals that, set them equal to each other. So 3 to the 3x minus 1 is going to equal 9 to the x plus 4. Just like what we did up here, let's rewrite out 9 as 3 squared. So 3 to the x minus 1 equals 3 squared to the x plus 4. Over here, we multiply exponents. So that becomes 3 to the 3x minus 1 equals 3 to the 2x plus 8. Now that 3's are the same, then they equal each other. We could set the exponents equal to each other. 2x minus 1 equals 2x plus 8. Subtract 2x, subtract 2x. That gets me x minus 1 equals 8. Add 1, and x is going to equal 9. All right. Moving along, moving along, moving along. Find the inverse. Ooh, okay. Well, we'll write out y equals 3 to the 3x minus 1. Swap the x and the y. So that's going to be x equals 3 to the 3y minus 1. In order to drop that exponent down, what I need to do is I need to log base 3 both sides, because that will cancel you out. So log base 3 both sides. That gets me log base 3 of x equals 3y minus 1. Add 1 to both sides, so 1 plus log base 3 of x equals 3y. Divide everything by 3, divide everything by 3, and you get y equals 1 plus log base 3 of x all over 3. Probably a little bit friendlier to write it out this way. Now that I have y by itself, f inverse of x, but I'm going to write it out as 1/3 plus 1/3 log base 3 of x. And if you want to, you can make that like, the cube root of x. But I ain't. In order for me to do that guy, I really first need to combine the logs. Now let's just go traditional. Let's still do the whole y equals. I am going to combine at the same time. I'm going to combine. I'm just going to do it. You can't stop me. Log base 5 of 30x squared over 10x was my favorite type of sugar. So y is going to equal log base 5 of 3x. Now we'll swap. X equals log base 5 of 3y. In order to get rid of that log base 5, let's base 5 both sides, base 5 both sides. You cancel out, leaving us with 5 to the x equals 3y. Divide by 3, and y is going to equal 5 to the x over 3. So the f inverse is going to be 5 to the x over 3. All right, now we get to the inequalities. It's very important to understand that when you do inequalities, whatever you do to both sides still maintains the sign. So u being a greater than isn't going to change by doing what I'm about to do. I need to get rid of log base 2, so I'm going to base 2 both sides. That allows you to cross out, giving me 2x plus 6 is greater than 8. Subtract 6, subtract 6. That gets you 2x is greater than 2. Divide 2, x is greater than 1. Now let's make sure that 1 or anything above that can be plugged into the original guy. And it can. If I plug 1 into 2, I get 8. If I plug in anything bigger than 1, it's just going to be a bigger positive number. So you are going to be my final answer. So that we're going to get some weird in-between type stuff possibly with these types of answers when we do them. So just a big heads up, that is a strong possibility that that might happen. Okay, over here, let's add 4 to both sides. Let's add 4 to both sides, cross you out. That gets me 3 to the x plus 2 is greater than 27. Let's turn 27 into 3 cubed. So now that I have the same exact base, we could circle that, and let's keep that as greater than. X plus 2 is greater than 3. Subtract 2, subtract 2, x is greater than 1. Okay? All right. Again, we don't have to worry about plugging anything in. There's no logs to plug it into. Praise the Lord. Let's combine these guys, so that gets us log. We'll put it in a nicer order. 2 to the x minus 8 is less than or equal to log 3x plus 4. Log is less than or equal to a log, so let's get rid of the logs, leaving us with 2 times x minus 8 is less than or equal to 3x plus 4. Distribute. 2x minus 16 is less than or equal to 3x plus 4. I know what's going to happen. Minus 3x, cross u out. That's negative x minus 16 is less than or equal to 4. Let's add 16 to both sides, so negative x is less than or equal to 20. Divide both sides by a negative means you flip the sign. Okay. So when I look at these, plugging in negative 20, I can't do it. But I'm allowed to choose numbers greater than 20. So what I need to do is I need to find, and do I have the space? Let's just blow this up. No, I don't have the space. 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 All right, we'll leave it like that. So what I need to do is I need to find the smallest number that we're allowed to have. Okay, the smallest number that we're allowed to have. Okay, so I need numbers that are bigger than 0. So whatever x is, x minus 8's got to be bigger than 0, and 3x plus 4 has to be bigger than 0. If I add 8, I get x is greater than 8. Okay, so I'm allowed to plug in 8. If I subtract 4, okay, that gets me 3x is greater than negative 4, divide by 3. So x could be bigger than negative 4 over 3. Now, I have to choose the value that I'm allowed to plug into both of these and have still work. The smallest possible number that I can plug into this whole thing is 8. Actually, not even 8. 8.000000001. Because if I tried to plug in negative anything into there, it's not going to work. I can plug in 8. So I'm looking at this guy and saying, I know that's what I got. But that doesn't matter. Because I'm not allowed to plug in anything smaller than 8. So my final answer is going to be x is greater than 8. Because I'm allowed to choose any number I want that's greater than negative 20 as long as it's not smaller than 8. Very, very bizarre, very strange problem that hopefully you'll never see anything like it ever again. Ever. Forever. Sandlot. Okay. Can't do much here. Let's combine these guys. So that gets me, what? ln of 3 times x minus 6. ln of x plus 4 has to be smaller than that. So let's get rid of the ln's, just like the network did. See what I did there? Was it ABC? I don't know. Oh, ln DeGeneres. Please don't sue me if you find out that this is a thing. 3x minus 18. X plus 4 is less than that. Let's subtract 3x from both sides. That gets me negative 2x plus 4 is less than negative 18. Let's subtract 4. Let's subtract 4. That gives me negative 2x is less than rather negative 22. The Taylor Swift special. Divide by negative 2. Divide by negative 2. Flip the sign. X is greater than 11. Can I plug in 11? Yup. Can I plug in 11? Yup. So x is greater than 11. Oh, my head hurts. I'm having so much fun though. Ugh. Add 8. So 4 times the quantity 3 to the 2x is going to equal less than or equal to 324. Divide by 4. Divide by 4. 3 to the 2x is going to be less than or equal to, no way, 81. So I can rewrite 81 as 3 to the 4th power. Base 3 again. Set these guys equal to each other. 2x is less than or equal to 4. Divide by 2. Divide by 2. X is less than or equal to 2. I'm allowed to plug in negatives all I want, so let's do that. And yeah. Well, let's do a couple multiple choices, and then we can wrap this sucker up. Given the expression log base 4 x to the 16th, which is equivalent to a rational multiple of x, which of the following represents this expression when using the change of base formula? Gentle reminder, the change of base formula says log base b of m can be written as log of m, well, log base whatever of m over log base whatever of b. So I can do log base whatever of 16 to the x over log base whatever of 4. And it looks like what they wanted me to do is bring that x out front. And then also want me to base 10 this. I don't know why they made it base 10, but this should be x log base 10 of 16, because I could bring the x out front, over log base 10 of 4. No, you can't simplify those. All right, use a calculator. I was hoping to avoid this. Given the function f of x equals that guy, which of the following intervals is f of x greater than 0? So let's run to our TI-84 plus. Let's graph it and find out where you land above the x-axis. All right, so the annoying thing about this is log base 4, no big deal. Hit y equals. If you go to, do I need to type out anything? Nope. I'm just going to graph this, go to math, hit up a few times to log base, and that allows me to type in base 4. Go to the right, x minus 3, go to the right again, plus, hit math again, go up a few times to log base, hit 4, x plus 2, and we care about where this is going to cross the x-axis because we want it greater than 0. So since there's a log, right, you can't have negatives. So we didn't do anything wrong. So what I need to do is find out where it crosses the x-axis. All right, so let's zoom in on that. Let's zoom in. That looked where? Where did that, like, so right around the 3-ish. So let's really zoom in between 1 and 5 just for funsies. So actually, let's go to window. And let's change this from 3 to 5. I shouldn't have done 3 to 5. I should have done 1 to 5. There we are. So let's find the 0. So second calc, 0. So I have to, there we are. We're barely below the x-axis. So let's hit enter while we're there. Go to the right, hit enter again, and that happens to be 3.1925, so 3.193. So let's go back and write that out. All right, so our magic number was 3.193, so x has to be greater than 3.193. I left all that space for nothing. Oh wells. Oh wellsies. By the way, the long version of this is basically what you would do is you would have to do quadratic formula. Maybe one of these days I'll do another one like it, but nah, we already did quadratic formula. We're good. Solve the equation log of 2x plus log of x equals 2. So that's going to be add these guys, which means multiply the insides, log of base 10 2x squared equals 2. Can't pull out the 2 because it's not connected to the 2. So what we could do is base 10 both sides, base 10 both sides, cross you out. That gets me 2x squared equals a hundo. Divide by 2, divide by 2. X squared is going to equal 50. Square root that. Don't forget the positive or negative symbol. So since that's 25 times 2, I can pull out a 5, leaving us with plus or minus 5 root 2. Am I allowed to plug in negative 5 root 2? No. Am I allowed to plug in positive 5 root 2? Yes. So my answer is positive 5 root 2, which is you. So you probably heard somebody yell in the hallways here where I work. It's a joy. That's that. That's that. Make sure you go to Math Teacher Goat and write out 2.13, AP Precalculus 2.13, and see what random videos pop up. Help further your understanding. Don't forget to like and subscribe. Thank you for watching. Have a wonderful day. Bye.